Good morning, Year 8. Thank you again for engaging with these lessons. If you could please send me that message on Show My Homework to show that you've accessed the lesson, that would be absolutely fantastic. Today's lesson is going to be assessed via some self-marking as normal during the lesson itself with the answers on the video, and there's also a My Maths activity as a plenary activity to assess your knowledge on mass, density and volume we're looking at today. So, developing students are going to be able to calculate the volume of prisms. We'll cover that in our examples that we're going through today. Secure students are going to be able to answer simple questions to do with mass, density and volume, and then excelling students are going to be able to answer exam questions involving those. Some of those in the worksheet. There's also going to be an extension sheet available for those that would like a challenge. So our quick starter for today. These two objects, the brick and the sponge, are the same volume, but in water the brick would sink and the sponge would float. Why is that? So this is linked to today's topic, which is our mass, density and volume. Now we're told that the volume of these two objects is the same, so that can't affect whether one would sink or float on alone. The mass as well alone does not affect whether something sinks or floats. So the brick would sink obviously and the sponge would float. The brick has a greater mass, but mass alone doesn't dictate whether something could sink or float. If you can imagine a cruise ship, for example, much heavier than a brick, but a cruise ship floats, whereas the brick sinks. And this is all down to density. Now, density is our next compound unit. Density links mass and volume together. So we're making comparisons with these shapes. For the same volume, the brick has a much higher mass than the sponge. So the brick would sink, but the sponge would float. This is down to its density. So we're going to start to calculate density today. So what is density? Well, density is the amount of mass in a certain volume, and it tells us how tightly matter is packed together. So if we look at a couple of examples here, we've got two squares here, and this one is absolutely jam-packed of these dots. So this one would have a higher mass within that same volume, and the other object has these dots much more spread out, so it has a much more loosely packed amount of dots in it. So this would have a lower mass within that same volume. So the object on the left here is going to have the higher density, and then this one here would have the lower density. You might think of this packed as a tight structure of the atoms in the shape, so this might represent the brick on the left, and it might represent the sponge on the right, or similar. Now, as we're looking with our compound units, this follows on directly from our speed, distance, time. Our compound unit of speed told us distance travelled in a certain amount of time, meters per second or kilometers per hour. Density is also given as these units, compound units, but in this case we're linking our mass and our volume. So it might be, for example, our first one here, grams per centimetre cubed, and here kilograms per metre cubed would be units of density. Now, remember with our compound units, we've got a nice little hint of how to work them out given in the unit itself. Here we've got grams / centimetre cubed, so actually to work out the density of this object, we'd need grams divided by centimetres cubed, or grams is a mass, centimetres cubed is a volume, so mass divided by volume tells us how to work out density. So we can link that again into a triangle formula. The triangle's really nice. I'm hoping that you've looked at those in science as well. But it gives us these three formulas again. We can use that triangle by covering up one of the letters that we're after. So if we were trying to find mass, we can cover up mass in the triangle, and we have D next to V. Remember, those letters next to each other in algebra mean times together. So D times a V, density times volume. That gives us our mass. Likewise, if we're working out the density of an object, we could cover up the letter D, and we have M above V. So M above V is going to give us mass divided by volume to give us density. And finally, we could then have a look at finding out volume. So let's cover up the V, and we have M divided by D. So that's going to be mass divided by density. So an example of that triangle will be great in your notes, so you can use that going forward in the lesson. So, specific things to watch out for in these questions. The use of the formula itself is fairly straightforward, but we need to look out for consistency of units. You may be asked to give a density in kilograms per meter cubed, but some of your measurements are in grams or centimeters. You need to convert them into those consistent units. It's handy to do that first. Do we need to calculate volume itself before we start? You might be given the measurements of an object, but not actually its volume. Watch out for converting your cubed or squared units if they appear in questions as well. Here we've got a cube that is 1 meter by 1 meter by 1 meter. That's really nice because it's going to be 1 meter cubed. But when we're converting that into perhaps centimeters cubed, we can't just say, oh, there's 100 centimeters in a meter, therefore 1 meter cubed is 100 centimeters cubed. That's not correct. We've got to actually convert all of our units first. So here we've got the object on the right. We've taken away all of the meters and converted them into centimeters. So you can see here that the 1 meter has turned into 100 centimeters. So is this one. Almost missed it with the arrow. And so has this one. Now, if you're working at the volume of a cuboid, then we do length times width times height. So actually we need to do 100 times 100 times 100. So that's actually going to give us 1,000,000 centimeters cubed. So another way of looking at this is you take your sort of conversion rate, which is 100 for your regular units, and because we are looking at cubed units, our conversion rate is actually that 100 cubed, 100 times 100 times 100. So if you had an object that was 7 meters cubed, it would be 7,000,000 centimeters cubed in it. Sounds like a huge amount. If you imagine a cube that's a meter by a meter by a meter, that's actually quite a big cube, and a centimeter is very small. If you imagine a very smaller than a regular dice, it'd be 1 centimeter by 1 centimeter by 1 centimeter. You'd need 1,000,000 of them to fill that box up. So look at some practical examples then. So here we've got a cuboid. It has dimensions of 9 by 3 by 12 centimeters. It has a mass of 994.4 grams. Find the density of the cuboid. So here we're going to have a look. Let's cover up density. We've got mass divided by volume. The mass is quite handily given to us here, but the volume we don't have. So you need to remember your volume of a cuboid formula, length times width times height. So first off, you're going to do 9 times 3 times 12 to work out that volume. Pardon me. So the volume of the cuboid is 324 centimeters cubed. Now we can run our calculation. Density is mass divided by volume. So we can do our mass of 194.4 divided by our volume of 324. That's going to give us 0.6. We now need to have a look at what units we've got. They're circled in green there. So our mass was in grams and our measurements of our cuboid were in centimeters. Therefore, the volume was in centimeters cubed. So our density unit here is going to be 0.6 grams per centimetre cubed. So make sure you're getting the units on this. There's a couple of people sending in their speed, distance, time questions last lesson and didn't have the units on. It's critical in these questions and you would lose marks in an exam without the correct units on. So a different cuboid here. This one has measurements of 2 meters by 90 centimeters by 140 centimeters. It has a density of 0.8 kilograms per meter cubed. So find the mass of the cuboid. Here's where we need to be really careful of our consistent units. We've got meters here, but we've got centimeters in these units. Now, if you're going to ask yourselves, well, which do we convert? It doesn't really matter, but have a look at our density is given in kilograms per meter cubed. Well, if our density is given in relation to meters cubed, it would be handy if all of our measurements of our cuboid were in meters first. So let's work out the volume of this cuboid. Remember, if we're going to work out the mass of the cuboid, we need density multiplied by volume. So volume of this cuboid, and we're converting into meters here. So 2 meters is still 2. 90 centimeters turns into our 0.9 meters, and 140 centimeters turns into our 1.4 meters here. So we can get our volume of this object being 2.52 meters cubed. We can then run the formula as normal. So we need density times by volume. So we need our 0.8 multiplied by our 2.52. That's going to give us 2.016. Let's check our units. We had all of our measurements in meters, which was great, and our density was given in kilograms per meter cubed. So our mass must be measured in kilograms. And we're done with the question. So here we have a cylinder with a mass of 270 grams. We have a density of 0.78 grams per centimetre cubed and a height of 9 centimetres. Find the radius of the cylinder. This is a much more complicated version of the question because we're now doing a little crossover into our volume topics. So we need to be aware later on in the question of the volume of the cylinder formula. So radius is going to be some kind of measurement of the cylinder, and what we know about the radius is going to be linked in with the volume of the cylinder formula. In these problem-solving questions, we've got to think, well, we've been given the mass. Let's highlight these on our title here. So we've been given the mass, we've been given the density, so we've covered off density, and so even though we are asked for the radius of the cylinder, the only thing we have left in our density, mass and volume formula is volume to work out. So the first step here would be to calculate the volume of the object, and then we can see if we can go any further with it. So let's have a look at the density, mass and volume portion first. So if we need to work out volume, we'll be doing mass divided by density. So the mass of the object, I'm going for yellow of these, so the mass of the object is 270 and the density is 0.78. Are our units consistent? Well, yeah, this one has grams in it and then this one has grams per centimetre cubed in it. Yeah, so our units are consistent, so we can run the formula. So volume's mass divided by density, so 270 divided by 0.78, and that gives us 346.1538462. I would probably round your answer appropriately, so 346.2 if you were rounding to one decimal place, or 346.15 if you're going to 2 decimal places. But definitely keep this answer accurately on your calculator for the next step. So if you can save it in the memory, or even if you have to write that down in full somewhere, that would be fantastic. But now would be a lovely time to check. You can check online on how to use the memory function in your calculator, or leave it on the answer line if you've got a class whiz, and the next sum will be able to take that in. Now we've got the volume then. If our measurements for our density involved centimetres cubed as the volume measurement, then our units here are centimetres cubed. So we can now move on to the second part of this question and get the radius of the cylinder. Well, we now have a answer for the volume of a cylinder, so we've now got to apply that to the volume formula for a cylinder. So volume of a cylinder is pi times the radius squared times by the height of the cylinder. Have we got any more information about this cylinder? Well, yes, we've got the height given to us. Height here is 9, so we can replace h with 9. Now this then means that for our next step we can then start to rearrange this function. So we had 346.15 is our radius squared times by pi and times by h. So to get the radius squared on its own, we're going to be dividing our 346 by pi and dividing it by the 9 that we got for the height. So that gives us 12.24 for our radius squared. We obviously need to square root then to get our answer, and that gives a radius then of 3.4989, and we'd round that appropriately as required in the question. Don't forget the units, we're going to need a centimetres on that as well. So rounded here to 1 decimal place, but have a look in questions because it might ask for a specific one. I know in my maths activities especially are very particular about rounding on these. Other things just to watch out, of course, if you're square rooting a number, the positive and negative values would be appropriate. However, in a contextual question like this, it doesn't make sense to have a negative radius for a shape. So obviously just going to take the positive value there. So this might be a little bit odd, but we're going to have a go at some socially distanced bingo here. So I'm going to ask you to write some numbers down in a 3x3 grid. So you're going to write down 9 numbers of your choice from the next slide. I've then got 12 mass, density and volume questions, and the aim here is to get yourselves a full house. So I will have to just trust that everyone has their integrity here and isn't going to cheat on this. But if you do manage to get a full house in those 12 questions, you can send me a picture of your bingo grid completed and I'll be able to issue you some reward points. So we'll see how this one goes, but I will have to trust you being honest on this one. So if you've drawn yourself a 3x3 grid, then I'm going to ask you to choose 9 of the numbers from the grid here to pop in yours, and they can be popped anywhere. So we've got 16 numbers to choose from. You need to pick 9 of them. Once they're placed in your grid, then we can continue. So pause the video until you've got your grid done. Obviously no repeats, because if you put the same number 9 times, you're going to get your grid filled immediately if that answer comes up, although it's big risk. And then let's move on to some questions. So find the density of a piece of wood weighing 6 grams and having a volume of 8 centimeters cubed. So if you'd like to pause the video until you've worked this one out, then we can run through the answer and we'll have a look at what you should have in just a second. So if we're working out density of an object, we need mass divided by volume. So we're looking for our 6 divided by 8, which is going to give us a 0.75, and our units here, grams per centimetre cubed. So cross off the 0.75 if you're lucky enough to have it in your grid. So next question then, calculate the volume of a liquid weighing 4 kilograms and having a density of 1.25 grams per centimetre cubed. And pause the video until you've given this one a go and we can run through the answers. So answers to this. Calculate the volume. Well, volume is going to leave us with mass divided by density. The big problem here that might have given a few people a mistake on this one is our mass of the liquid is in kilograms, but our density is in grams. So here, although we're looking for volume to be mass divided by density, we need 4,000 divided by 1.25, and that will give us 3,200 grams as our answer. So you can cross off 3,200 if you've got it. Next question then. A 1 kilogram bag of sugar has a volume of about 625 centimeters cubed. What is the density of the sugar in grams per cubic centimetre? Pause until you're ready. I'll run through the answers now. So if we are after density, we need mass divided by volume. Again, watch out for units. We're after grams per cubic centimetre. So grams here isn't going to do, because we've got kilograms there. So we actually need 1,000 divided by 625 to give us a 1.6. Next question, calculate the volume of a piece of wood that weighs 102 grams and has a density of 0.85 grams per centimetre cubed. So pause until you're ready. I'll run through the answers now. So volume is mass divided by density. We have the correct units that match here, consistent units, so that's fantastic. So we can do 102 divided by 0.85 gives 120. So find the mass of a marble model of 56 centimeters cubed in volume if the density of the marble is 2.8 grams per centimeter cubed. Pause until you're done. Answers then. We've got mass, so we need density times by volume. We've got consistent units, fantastic. So density times by volume is going to give us 156.8, and our mass then would be in the same grams as was in our density compound unit. So I bought a 50 kilogram bag of coal and estimated the total volume to be about 28,000 centimeters cubed. What's its density in grams per centimeter cubed to 2 decimal places? Well, if we have some pause time now and running through the answers, if we are after density, we want mass divided by volume. We don't have consistent units here, grams and kilograms, so let's convert our mass of the bag of coal into grams first. So 50,000 divided by 28,000 is going to give us 1.79 grams per centimeters cubed. Watch out for the rounding there. Yes, you've got 1.78 as your pure decimal places, but after that 8's a 5, so we need 1.79 when rounded. So find the density of the material of a pebble, which weighs 34 grams and has a volume of 12.5 centimeters cubed. Pause. And the answers then, density is mass divided by volume. We have got grams and centimeters cubed here, so we can run that as our density. So mass divided by volume, 2.72. So much more difficult question here. Oil has a density of 800 kilograms per meter cubed. Convert this into grams per centimeter cubed. There's involved a fair bit more thought on converting your units here. So I'm going to give you a moment to have a think about this one, and we'll run through the answers. Okay, answers for this one then. We should have 2 steps to take. So the first thing to do, they've done in this calculation here, is they've converted the meters cubed into centimeters cubed. Obviously, if we're going from meters cubed down to a centimeter cubed, we're getting much smaller in volume. So we're going to divide by that million scale factor here. If we're going from kilograms to grams, though, we're also going to need to times by 1,000. Our original weight of 800 kilograms was 800 times by 1,000 grams. And that's overall going to give us 0.8 grams per centimetre cubed. So have a think, the original mass is going to be a much larger amount of grams, so we need to times, but then we're now scaling down what volume we're looking at, so we need to divide by that scale factor to turn our metres cubed into centimetres cubed, so quite a bit more difficult there. A block of lead has a volume of 540 centimetres cubed and a mass of 6.156 kilograms. Find its density in grams per centimetre cubed. So pause time for your question. I'll run through the answer now. Density then, mass divided by volume. Volume here, yeah, centimetres cubed, we've got consistent units, but our mass we haven't. So we need to convert that kilograms into grams. So we're after 6,156 divided by 540 to give us 11.4. So a statue is made of metal of density 8 grams per centimetres cubed. Find the mass of the statue if its volume is 30 centimetres cubed. Again, pause time until you've done. And answers as follows. So we're after mass, so we're after density times by volume. We do have consistent units, so that's fantastic. So we can multiply those together to give us 240 centimetres cubed. So it is estimated that the statue of Queen Victoria in Endcliffe Park, Sheffield, has a volume of about 4 metres cubed. The density of the material used to make the statue is 9.2 grams per centimetres cubed. What is its mass? We've got a couple of ways of thinking of this one, so be careful. Pause until you're ready for an answer. So if we run through what's required here, it can be a bit of a tricky one to do here. The problem is our lack of consistent units. So we've got 2 ways of doing this. We could deal all in centimetres cubed, so we could get our mass of the object being in centimetres cubed first. It's going to be 4 million centimetres cubed, and then we can do density times volume, so 4 million times by 9.2 grams, and then convert that into our suitable units. Or we could go down what I think is probably the more difficult route here, of turning our 9.2 grams into grams per centimetre cubed into kilograms per metre cubed, via the method we talked about in the previous slide. That's the one I'll display underneath for those that are checking the more difficult version. I would definitely suggest here that the majority of us should be doing our 4 million meters cubed times by our 9.2 grams per centimetre cubed. Obviously though, that gives us a huge answer in grams, so it'd then be useful to convert that back into kilograms. So if we're doing 36,800 kilograms is going to be the mass of the statue. It'd be possibly you could have that as 36.8 tons as well, but 36,800 is going to be one of the numbers that we can cross off on our bingo grid. Even if you went further into tons, you can cross off this one as your answer in kilograms. Next one then, the volume of a solid object is 5 centimeters cubed and its mass is 50 grams. We calculate the density. Pause until you're ready. So density is mass divided by volume. Lovely consistent units in this one. So mass divided by volume is going to give us 10 grams per centimetre cubed. So cross off a 10 if it's on your grid. So if you honestly then manage to cross off your 9 squares of the grid, well done. Please send me a picture of that on Show My Homework, no fibbing. And if you can, please stick to Show My Homework for that. That way I can save my email address to be used for just people that need some support with their work. That'd be fantastic. We can now decide how confident we feel with this topic. So we've got a couple of choices of activity to have a look at. If you've got loads of time, then you might be able to do both. But I'd imagine some of us here might only be able to get through one, and that's fine. So the first option is we've got our red, amber and green activities. Remember, you only need to do one of those. This is the attached worksheet to the Show My Homework. So red activity is for those that need quite a bit of support and frameworking with their questions. Amber is just for those people that need a little bit of a hint to get started on the questions, and green has no help at all. So they're all the same questions, it's just that varying level of support, so don't do all 3 of those. So that's one of your options, the linked activity. And I've also set you a My Maths homework on mass, density and volume, so you could have a look at that as well. So if you've got time now in the lesson to get through both of those, that'd be absolutely fantastic. But with the time remaining after you've done some working out, if you've only got time for one of those, obviously that's understandable as well. So answers coming up to the written activity in just a moment. Obviously the My Maths is self-marked, so again you might want to pause until you've had a go at the written activity. And answers coming up. So answers as follows. There's a couple later ones where you might have a little bit of a choice. So 7B here, we could either go for grams or kilograms. Obviously we've got a high amount of grams there, so kilograms might be the more suitable unit. And the same here with 8A. We've got a high amount of millimeters cubed, so you may have gone for centimeters cubed to make it more reasonable. In other questions, you might have done the same. So if you're thinking that we've got 20 grams here, for example, in question 2A, if you had your answer in kilograms, well, you're going to have a decimal number, so it might not be particularly suitable. But if you're unsure about the conversions, do let me know. So, as always, thank you for engaging with these lessons. If you haven't sent me the message on Show My Homework yet, then please do so I can put you on the online register. We've had our self-assessment via self-marking and the My Maths, or one of those perhaps if you were running out of time. And then please get in touch with me at red@theroyal.school if you do need any help at all with this work. Thank you very much.